in this week's adventure, we're going to talk a little bit about about basic types, fundamental types. So we're going to talk about integer and floating point numbers and understand when to use what. Get you familiar a little bit with rounding errors. I actually caught a couple of them this week. Not that you prevented it. When to use constants, arithmetic, when to use strings, and write programs to read input and produce formatted output. This should actually be pretty straightforward because this is pretty basic stuff. Like I said, if you guys have had other classes, it shouldn't be hard. So in Java, there's two types of variables, or every value. You either have a reference to an object, equivalent of a pointer, or one of 8 primitive types. So it's either a type of integer, a type of floating point, a string, or what's the other? A byte. So, and a Boolean. So basically, here's all the primitive types. You've got, integers, a byte, which is just a tiny integer, short, which is a 16-bit integer, long, which is a 32-bit integer, or 8 bytes, or I'm sorry, it's a 64-bit integer. You got double, which is floating point, and float, which is a single precision floating point. Almost everybody uses double instead of a float. Let's see, char represents a character in the Unicode encoding scheme, which basically means it takes 2 bytes instead of 1 because it can do internationalization. A Boolean is true or false, and it's tiny. So number literable, a number that appears in your code. If it is a decimal, it's a floating point. If not, it's an integer. If you can't understand that, you probably should take a class. Now here's some examples. The only one I'll point out here is actually using the exponential format, or you can specify something as a long by putting an L after it. Obviously, you can't use a comma, can't use fractions. You guys have used a computer before, so it shouldn't be rocket science. So overflow occurs when you exceed the value of a range, and if you go bigger than an integer can hold, it doesn't throw an error, it just wraps it around. So the way to get around that is to use a long instead. Double data types don't have that because the numbers get really big. Rounding errors occur when an exact representation of a floating point number is not possible. Not every value can be represented precisely, so you can get round-off errors. Use double type in most cases to reduce these. It can be a pain in the butt, but it's also not that frequent. So when you want to use symbolic names whenever possible. You don't want to say 3.14. You want to say pi. You don't want to say quarter. You don't want to say 25 cents. You want to say a quarter. In Java, you can declare a constant by using the keyword final. So you'll say final double quarter value equals 0.25, and you can replace the 0.25 with quarter value. Then use it in any expression. For some odd reason, Java uses all uppercases and underscores for their constants. If you have a constant that's needed in several different methods, you declare them together with instance variables of class, and they tag them as static and final. Basically, it means instead of belonging to a method, the constant belongs to a class. As a general rule, I usually make all my constants static constants. Give static final constants public if you want other classes to be able to use them. For example, math uses public static final pi to give you pi out to 15 places or something, and then you can use the constant in your calculations. Make sense? If there's any questions, feel free to pipe in. So basically, constant declaration, we have if it's in a method, we have to give it just the word final. If it's in a class, you'll give it a public or private modifier. Static says it's for the class, not just for the method, and pretty straightforward. There's a really simple example of a cash register. Basically, we declare constants for quarters, dimes, nickels, and pennies, and we construct a cash register with no money in it. We record a purchase by adding the amount to the purchase, and we can then do nice things like record a purchase and then print the output and use constants instead. So this one should be really basic. Plus, minus, times, divide. You can mix variables, literals, operators, and metals. Parentheses control override the order of operations. Multiplication and division have a higher precedence than addition and subtraction, just like everywhere else. Mixing integers and floating points yields a floating point value. 7 plus 4.0 would be 11.0. Does that make sense to everybody?
Yeah, it makes sense.
Okay. Plus and minus work just like they do in C++. Anybody have any questions about that? It should be pretty clear. Division works as you expect as long as at least one of the numbers is a floating point number. If both numbers are integer, the result is an integer and the remainder is discarded, so it just throws them away. 7 divided by 4 evaluates to 1, because 4 goes only 7 one time.
C++2.
Yeah,
we learned about it. And discrete.
Yeah, 121 we learned about it.
So here's some examples. Number of dollars, remainder, get the remainder from dividing by 100. Pretty straightforward. Just a table of stuff. Powers and math. The math class contains methods like square root and power and floor and ceiling, a bunch of other stuff. So to take the square root of a number, you just call the square root function. To compute x to the n, it's this simple. So this example, b times 1 r over 100 to the nth, can be represented like this. So here are some mathematical methods they have in there. So you can go integer to double, but you can't go the other way because basically it has to lose some information to do so. If you need to take a double and pop it into an integer, you have to cast it to integer, in which case it truncates the floating point part. Does that make sense?
Is it kind of like static cast in C++? You're just casting it to a different type?
Yeah, basically you cast it to a different type, and it literally truncates the difference. It's not rounding. Math.round will actually round to the nearest integer.
Okay.
So, but when you cast it, you're truncating it. So the cast is just the name of the cast in front. You don't have to use any of this the goofy C++ nomenclature for it. If you want to cast an entire expression, make sure to put it in parentheses. So here's some more examples. Here the parentheses are required because you want to group x plus y. You'll see here, for example, instead of using math power a2, well, a times a is simpler, so you might want to use that instead. There you go. Now, unlike objects, numeric types are not objects. This differs from languages like C++, C#, where you can literally do things on objects of type number, because it uses a magic thing called boxing and unboxing. But so to call square root on a number, you'd have to use a static method. A static method doesn't operate on an object. It is declared inside a class. It's kind of like in C, if you have in C++, if you have a function that's not part of a class, it's kind of like that, but they're contained in a class. You declare a static method in a class, and you call it by giving it the class and the name of the static method and any parameters. So, reading input. When a program asks for user input, it should first print a message and ask for it. Print, please enter the number of bottles. This message is called a prompt. use the print method, not print line, because print line throws a return in there. System.in has a minimal set of features and must be combined with other classes to be useful. If you use a class called scanner to read keyboard input, you'll be able to do some fun stuff. So you create a scanner object by sending it the input stream. So in theory, you could later send it a file instead of the input. NextInt will read the next integer. The program waits until the user types a number and presses enter. The number is placed into the bottles variable and you're done. Next double will get a double. You got to import the class or you can't use it. So here's some some detail. Use this line to include the class we need, create a scanner object and make it use the system.input. Be nice and display a prompt and get the variable you want. So when we want to format our variables, you use the printf method. And what's kind of funny is in C++ you don't use printf anymore, but printf came from C originally. So here, for example, instead of this big crappy ugly thing, you can say only print the two digits to the right of the decimal point of a floating point number. You can also specify a field width, 10 characters, which would be 6 characters followed by the 4 characters 1.22. Let's look back here for 1 second. Yeah, 1.22. Basically, what this will do is pad it to the right. And the total number of characters, the total number of the string, it's not 10 and then the characters. So this is how we can line up our columns and make our stuff look nice and neat. So here's some examples. %d is an integer. 5d is a integer of width 5. Okay, you can put words inside there. 2 digits after, total of 7 with 2 on the right. Use a string, and you can format multiple values at once. You just trail them in the print line statement. So here's an example. System.printf. Here you can see we've got the specifier for this variable, specifier for this variable. Now, in Java, if you don't have one of these variables, it will let you know. Unlike JavaScript, for example, which will just let you do it until your program blows up. All right. So here's an example of some nicely formatted stuff. Whoop. And it lines up our stuff really nicely because we use the 8.2f to make them both the same size. So when you're developing an algorithm, one thing you want to do is try doing it by hand first to make sure you really understand what you're doing. For example, here, there's this black and white tile problem. Compute the number of tiles needed and the gap at each end. Well, use numbers total of 100 inches. The first tile must always be black, and then we add some numbers of white-black pairs. So basically, you do the computation, and you can find what the gap is. You need to understand what a problem is before you can write a program to do it. So now building an algorithm, here's some pseudocode. Basically, the integer part of the total width minus tile width. Number of tiles, 1 plus 2 times the number of pairs. Whoops. And the gap at each end. So basically, we took a problem, we ran it through and built an algorithm that we could solve, and then we built a small program to do it for us. So a string, similar to a string in C, it's a sequence of characters. String variable holds a string. String literals are character sequences enclosed in double quotes. Length is the number of characters in the string, and it doesn't include the terminator. The length method yields the number of characters in the string. A string of length 0 is called the empty string and is written as double quotes. So when you concat strings, you add them together to make a longer one. So Harry Morgan would be Harry Morgan. Notice no space. If we want to get a space, we got to put it in there. So this is an interesting peculiarity. It will auto-convert other types where it can to be compatible with string. So we've got an agent and we've got an employee. If you add them together, it's going to convert the 7 to a string. You can also do it right in the print statement. So you can combine multiple print statements. So for the scanner, you use index to read a word. It stops at a space or a break. So what if you have special characters like a quote? Well, you can prefix it with a backslash and it will do what's called escaping the character. Basically, keep it as part of the string and mark the end of the string. To include a backslash, you use 2 slashes. New line is /n, that's old school. /t is a tab. This printf is the equivalent of a println. So what is Unicode? A string is a sequence of Unicode characters. Characters are valued of type char. Characters have numeric values. Character litters are delimited by single quotes. Don't confuse them with strings. Now, one thing is, because we're using Unicode, each character takes up 2 bytes, not 1. You start a string position at 0. So when you do substrings, you go from 0 on. Char at returns a char from a string at a particular position. So start char at 0 would be H, and the last would be Y. Substring method extracts a part of a string, start and to the past end. Why does it call it past end? That's weird. Basically, it's not inclusive. So 0, 5 would give us 0, 1, 2, 3, 4, up to 5, and it will include the comma. Starting at to extract row, we got to start at 7 and go on to 12, and minus start. Okay, this is I believe this is the same in C++. If you omit the end, it goes off all the way to the end. Here's some common examples. Whoops. A little program to read in a first name and your next name. See how we reach each word. Grab the first character and grab the first character of the second, and there's your initials. All these wonderful string operations. I will leave these to you to study at your own leisure. So, talking a little bit about international alphabets, a German keyboard is slightly different than an American. You can have a Hebrew keyboard. Now, if you notice here, we have a whole bunch of other characters that aren't in the normal English alphabet. Now, what's interesting about things like Hebrew is you read it right to left. So not only do you have to accommodate for characters, you have to accommodate for direction. And that is a bit trickier than just taking care of the printing. You have to do things like set a culture and use code pages, all sorts of fun.